So for B, you should have filled that in with a second. We take the score minus the mean and divide by the standard deviation. Remember, the standard deviation is 10. Fill in the table and then make a dot plot for each. So pause and then come back and check your dot. So I meant pause and come back and check your table. So that's what your table should be now. And now pause and come back and check your dot plot. So it should look roughly like that. So what we are actually showing, so this is where you want to bring in that second color. This dot plot is our distribution of z-scores. And what we call this is it is our standardized distribution. So in a standardized distribution, that means you're going to have a mean of 0 and a standard deviation of, in this case, it was 10 divided by 10, which is 1. So in a standard distribution, a distribution of z-scores, your mean will always be 0, and your standard deviation will always be 1. That's going to be important. It might come up on your quiz. So what happens to the shape? Well, we still have that same shape. So our shape is the same. Our center, well, we just talked about that. Our center, it is the same as our last one. So when we looked at the distribution of the score minus the mean, it's the same as that. So make a note, this is compared to score minus mean. So it's the same at 0. Also, it's actually divided by 10, which we did 0 divided by 10, which is still 0. So 0 divided by 10, still 0. So that's why it's the same as that last one. If we were comparing to our original one, because we divided by 10, our center would also divide by 10. And then our variability, it actually decreased. Now, why is it decreasing? Because we divided by 10. So decreased by dividing by 10. And this will always happen. If you're transforming data by division, it will always decrease by a ratio of what you're dividing by. So in this case, our variability decreased by a 10. So to summarize, what happens to shape, center, and variability of a distribution when you add or subtract the same value from each value? So remember, our shape is the same. The center is either plus or minus a, where a is that value. So in this case, we subtracted 80, so our center reduced by 80. But your variability remains the same. Our shape, when we multiply or divide by that same value, and this time we're calling that value B. Your shape, still the same. Your center is now your value. So it's either times or dividing by that value. So if we were multiplying, then your center would be times that. So think about it like when we were transforming in geometry, when you have a dilation and you have that scale factor, that's what's happening to your center. It's almost like it's a scale factor. We're either multiplying or dividing by that value. So, and then our variability will also multiply or divide by that value. So once again, similar to that geometry, a scale factor with a dilation. What is the mean and standard deviation of the distribution of z-scores? Will this be true for any distribution of z-scores explained? This, your mean, will always equal 0. And your standard deviation will always equal 1. So why is this? Oops, that was supposed to be a z. Z-score is your value divide or minus your mean divided by your standard deviation. So when we are transforming and we're taking our mean minus our mean and then dividing by that standard deviation, well, that mean minus that mean is always going to cancel out to 0 divided by your standard deviation, which is still going to be 0. And then as far as standard deviation, when we transform it, it ends up being standard deviation over standard deviation, which is going to equal 1. So that is always true. Remember, it might come up on your quiz, so keep it in mind. So let's check our understanding. I strongly encourage you guys to try these problems yourself and then come back to me to check. So we have, suppose you convert the time before changing sheets from days to weeks. Okay, sorry. Suppose you're converting the time before changing sheets from days to weeks. So we're given this in days and we want to convert it to weeks. Describe the shape, mean, and standard deviation of the distribution of time before changing sheets in weeks. So let's think about that. If we're going from days to weeks, well, how many days are in a week? 7. So we would need to divide by 7. So you're really transforming this by dividing by 7. So shape, when we divide, is the same. So the shape of the distribution is the same as in days, skewed right. Right, and then our mean in weeks would be that original 42.75 divided by 7, which would end up being 6.107 weeks. Guys, you should change your sheets more than that, just saying. Standard deviation. So, and once again, in weeks, it would be a similar process. We would take that standard deviation, 34.984 divided by 7 equals 4.998 weeks. So that's how that would change. So the adults in the study are given an article explaining the health benefits that arise from changing their sheets more often. Yes. After reading the article, each person agrees to change their sheets 1 week sooner than they used to. How does the shape, center, and variability of the distribution compare with the distribution of time in part A? So now we're comparing B to A. So we're already in weeks. Now we know that everyone is agreeing to change their sheets 1 week sooner. So that 1 week sooner correlates with a -1. So shape, once again, is going to stay the same. I'm going to shorthand this. And that would be skewed right. Mean, so think back to that example we did. We were adjusting it by 80, so we subtracted 80. This time we're adjusting it by 1. So looking at part A, it was 6.107 minus 1 for that adjustment, and that's going to be 5.107 weeks. And then standard deviation. Remember, when we're just subtracting or adding, it stays the same because everything is shifting down, so variation stays. So stays the same. And remember, be specific. We want to give those weeks, 4.998 weeks. And then C. Now suppose you convert the time before changing sheets from part B to z-scores. What would be the shape, mean, and standard deviation of this distribution? Explain your answers. So if we want to do z-scores, remember that means we're going to 1, subtract the mean, and 2, divide by standard deviation. So once again, shape stays the same. Our mean, so essentially what we're doing is calculating that z-score, and that's 5.107 minus 5.107, because that's our mean, divided by our standard deviation, which was 4.998, which is really 0 weeks. We should know that, but you have to show the work for it. And then standard deviation is 4.998 divided by 4.998, and that is going to equal 1 week. And remember, all standardized distributions will have that mean of 0 weeks and that standard deviation of 1 week. So hopefully that made sense. If it didn't, I'll clarify when I get back. So yeah, now you guys are on to your quiz. Remember, you can use notes, work with your group, very similar to your check for understanding, so reference them. Good luck.